Okay, starting with number 3. It says the hand of a clock moves from 1 to 4 o'clock. Through how many degrees does it move? Okay, so you have a clock. And it says the hand of the clock moves from 1 to 4. And so how many degrees does it move? So last time in class we discussed that it was clear that from 12 to 3 we had a 90-degree angle. And so notice that it was 1, 2, 3 steps away. That gave us 90 degrees. Well, you could use that property and notice that from 1 to 4 you have 1, 2, 3 steps away. So therefore you're going the same distance, which gives you a 90-degree angle. So your answer is 90 degrees. You could do it that way. Or we also discovered that being that there were 3 hours in between 90, that means it splits up that 90 degrees into 3. And so each hour is 30 degrees, and you could say 1, 2, 3, so 30 times 3 is 90. So however you looked at it works, okay? Number 21. Use an algebraic equation to find the measures of 2 angles described. Begin by letting x represent the degree measure of the angle's complement or supplement. Okay, so you're using an equation to solve. And it says the measure of the angle is 12 degrees greater than its complement. So being that the key word in this problem is complement, that's what x is supposed to stand for. Okay, so imagine that you have an x right there, and it says the measure of the angle, talking about the other angle, the second one, is 12 degrees greater than its complement. So greater than means that we have to add 12. So this angle is x plus 12. And since they're complements, what do we know about the 2 angles? They have to add up to equal 90, right? So if I take these 2 angles and say x plus 12, they should equal 90 degrees. So that's our equation that we're going to use to solve. So any questions on how I set that up? Adding our like terms, we have 2x plus 12 equals 90. To get x by itself, subtract 12 from both sides, and that gives us 78. And then divide both sides by 2, and x equals 39 degrees. Good. So that's one of the angles. It also wants to know what the other angle is. So there's 2 ways that you could figure this out. We could just go back to this and say the other one is 39 plus 12, which equals 51 degrees. Or, since they're complements, you could say 90 minus 39 equals 51 degrees. Okay, either one will get you your second angle. Number 23 is similar problem. It says the measure of the angle is 3 times greater than its supplement. So this time x is going to stand for the supplement. And it says the angle is 3 times greater than its supplement. So the other angle can be represented by 3x. Good. 3 times the other angle, 3x. And then what do we know about these two angles? Right, you'll add them to equal 180. So since they're supplementary, these two, when you add them together, they must equal 180. And there's your equation to solve. So you add your like terms, and you have 4x equals 180. Divide by 4. Say that again? Oh, okay. So we get 45. Is that right? And then to find the other angle, you either substitute it back into 3x and find 3 times 45, which is 135. Or the other way you could do it is just say, well, since they're supplementary, 180 minus 45 also gives you 135. So you're given two parallel lines, and it tells you that those are parallel. And then you have two transversals. And then this angle is marked at 65 degrees. This angle is marked at 59 degrees. And you're looking for angles 1, 2, and 3. So if it's not 3 or 2, 1, but what about 1? Alternate exterior is correct. And if it helps for you to turn the pictures around, if you need to do this, okay, because you can see it better, or whatever it might be, sketch your picture and move it however you need to do it. But notice that angle 1 is on this line, okay? And the angle marked 65 is on the same line. They're both outside the parallel lines, and they alternate sides of that transversal. So they are alternate exterior, which means angle 1 is also 65 degrees. Okay, now what can we do? All right, so you got a straight angle with what? 2. Okay, so with 59, 65, and 2, if you look at this line right here, notice that all 3 of these together form a straight angle, which means this adds up to 180. So that means that if you take 180 and subtract the 2 angles you know, that's going to leave what you have left for angle 2. So subtract 59 and then subtract 65. Okay, 56, good. So this angle right here is 56. All right, so here's the 2 ways you can do this. Again, we're focused on this transversal right here. And so you might notice that angle 3 is the same. Now notice this transversal all the way to the parallel line. So this transversal all the way to the parallel line is both of those angles right there, and those are alternate exterior angles. So 124 is correct. Okay, so that's one way you could have done it. It's just by adding these 2 angles together. The other way that you could have done it is notice that angle 2 is alternate interior with this angle. And so you could have said, oh, well, if this is 56 and this is 56, and then these are supplementary, so subtract 56 from 180. All right, there's always going to be more than one way that you can find your answer. All right, so in either case, angle 1, measure of angle 1 is 65 degrees. The measure of angle 2 is 56 degrees. And the measure of angle 3 was 124, right? That's what we landed on? Because again, you could either add the 65 plus 59 together, and that gives you 124. Oh, and here's the other thing about the triangle. Somebody had told me, yes, these were vertical angles, but that was really irrelevant, and we may have never even looked at that in the first place. So again, you try to get there, a little bit faster with the information that you have. So if you eventually have to get there that way, then fine, but also be careful of what the diagram is that you're shown. So again, you have parallel lines, and then you have a transversal like this, and another one like this. And so these are the parallel lines. I'll put, double arrows here. So this angle is 72 degrees. This angle here is 52 degrees. And you're looking for angle 1, 2, and 3. Alternate what? Exterior. Okay, so are you talking about this angle or this angle? This one? Okay, good. So these two are alternate interior. And then what?
And then you can get angle 1 because...
I think I just said alternate interior, didn't I? Alternate exterior, sorry. Okay.
So you can find out angle 1 by subtracting our 180.
Good. Angle 1 and angle 72 are supplementary. So 180 minus 72 gives us 108. Okay. And so for, and I didn't write down the whole problem of number 39, but it said measure of angle 1 is equal to 38 degrees, and it wanted you to determine whether this was true or false. And so what did we just determine? It's false, right, because the measure of angle 1 is equal to 108. So number 43, so ultimately you have a right angle here, but you have another ray dividing that into two more angles. And this angle has an algebraic expression of 2x plus 50, and this one has one of 4x plus 10. So we have to use an algebraic equation to solve for x and determine the measure of these two angles. They don't equal each other. Right, when you add them up, they equal the 90-degree angle. So 2x plus 50 plus 4x plus 10 should equal 90 degrees. So getting your like terms together, you've got 6x plus 60 equals 90. Subtract the 60. So 6x equals 30. Divide by 6. X equals 5. Are we done? No, good. So it wanted you to actually find the measure of each angle. So now we have to take this 5 and, right, substitute it back into each expression. So 2 times 5 plus 50 is 10 plus 50, which is 60. Okay, so this one is 60. The other one has to be 30, right, because you know that they add up to 90, so you could work it out that way. Okay, knowing that 90 minus 60 is 30, or you could substitute this in. 4 times 5 is 20, plus 10 is 30. But you could also use that trick to just check your work, making sure it works both ways. And so you have the line that has the points A, B, C, and D on it. This is for 47 and 53. Okay, same diagram. So for 47, it wants you to determine segment AC intersected with segment BD. Okay, so AC is from here to here, and BD is from here to here. And so intersected means that you want what they have in common. BC is correct. So the part where they overlap, so that equals segment BC. So for number 53, you have segment AD intersected with ray DB. Okay, so this time instead of A to C, it's A to D. And then ray DB means that you're starting at D and you're going towards B, but since it's a ray, you're going to keep going. The second letter is just to tell you which direction you're headed. And again, you're looking for the intersection, what they have in common. So notice that they overlap from A to D. So that gives you segment AD. So any further questions there? All right, so don't forget on array, the first letter tells you where you start. The second letter tells you in which direction you're headed, but you want to keep going forever past that letter. So the first letter tells you where to start. The second letter tells you which direction to go and beyond, if you will. Section 10.2 focuses on triangles. Now, a lot of what we know about triangles is based on what Euclid learned about parallel lines. So you'll see how these two things correlate with what we just talked about. So Euclid, the author of geometry, he made an assumption that if you're given a line and a point that's not on that line, then one and only one line can be drawn through this point that is parallel to the given line. So that green line is the only way I can draw that line so that it is still parallel to the other line. If I draw it in any other direction, well, then it's not going to be parallel anymore. So there wasn't a way that he could prove that for sure. He's just making that assumption, okay, more of inductive reasoning. He, looking at a whole bunch of different lines, that's the only one that worked. So we know our triangle is a three-sided polygon. So if we take those parallel lines and we draw a triangle inside of it, so taking a look at your two parallel lines and you draw a triangle so that the base of the triangle is on a parallel line, and the point that is opposite that base, or it's called the vertex, just like the vertex of an angle, that vertex that is opposite the base is touching the other parallel line. It doesn't really matter how we draw this triangle. It could be perfectly symmetrical like the way we have it, or it could, point B could be over here. What I'm about to show you works for any type of triangle that we draw in here. So we know that the sum of the measures of the three angles inside of a triangle adds up to 180, but this is why we know it. First of all, note that angles 2, 5, and 4 all create that straight angle. So those three angles add up to 180. So let's take a look at that. So angles 2 plus angle 4 plus angle 5 equals 180 degrees. But what do you know about angle 2 and angle 1? Alternate interior is correct. Notice that they're both inside of the parallel lines and they alternate sides of that transversal or that left side of the triangle. So then that means that angle 1 and angle 2 are equal. So now let's take a look at angle 4. Angle 4 and angle 3 are also equal because they are also alternate interior. So we could also write this equation. Instead of an angle 2, I could write angle 1 because those are the same. Instead of angle 4, I could write angle 3 because angle 4 and 3 are the same. And then leaving angle 5 in there, I have just proven that for any triangle, because it doesn't matter where I put this point B up top, I've just proven for any triangle, all three angles inside the triangle add up to 180 degrees. Because they will always have that same relationship of alternate interior angles in those parallel lines. All right, so that's where that rule comes from. And now that you know that, you can learn a little bit more about their characteristics of the triangle. We can classify triangles two ways. We can either classify them by their angles or classify them by their sides. So on your handout, notice that you have two headings. One on the left says classified by angles, and the one on the right says by sides. So on the left, you're going to write this information. You're going to create two columns of information there. The first type of triangle is an acute triangle, where all angles are acute. It might look something like this, where all three of the angles inside the triangle are acute angles. A right triangle has one angle that measures 90 degrees. Why does it only have one angle that measures 90 degrees? Why not two? Well, because then you'd already have 180 degrees, right? You'd have no more degrees left for the third angle. So only one angle that measures 90 degrees. And so that triangle might look more like this, where you can mark one of the angles with the little box for 90 degrees. And that's your right triangle. And the third type that's classified by the angles is the obtuse triangle. This is a triangle where one angle is obtuse. So obtuse meaning that it's bigger than 90 but smaller than 180. So that triangle might look something like this, noticing that that angle is larger than 90 degrees. Okay, so that's the ways that we classify our triangles by their angles. Next, we're going to classify it by their sides. So this would be your right-hand column on your handout. An equilateral triangle is a triangle where all sides have equal length. So the three sides are all the same length in an equilateral triangle. Now it just so happens that when you have equal sides, then that means the angles are also equal. And since three angles have to add up to 180 and all three of them are equal, then they must be 60, 60, 60 in order to do that. An equilateral triangle looks similar to that first triangle that I wrote up there, the acute one, but just noting that all the sides are the same length. So I could mark the sides like that so that they show that they're all equal. An isosceles triangle only has two sides that have equal length. So maybe I'll draw it like this, where you can see that clearly these are the two sides that are equal and the third side is much shorter. Now, it just so happens that the angles that are opposite these sides, now an angle that is opposite something means that it's not touching that side. So this angle would be opposite this side, the one that I put a red dot on. And this angle would be opposite that side, because it's the angle that's not touching that side. Another way you can look at it is the two angles that are touching the third side are the ones that are equal. Okay, so these are equal to each other, the red and the blue. And then the third type of triangle classified by its sides is called a scalene triangle, where no two sides are equal in length. Okay, so it might look more like this, where you have a short side, a medium side, and a long side. So all three sides have a different length. Similar triangles is your next heading. And figures that have the same shape but not necessarily the same size are called similar figures. So it's not just with triangles, it's any shape. The ratio of corresponding sides are the same when the triangles have the same three angles. Okay, so your fill in the blanks weren't underlined here, so you need to read and see what words fall into your fill in the blanks. If you look closely, you'll notice that the angles they have corresponding angles that are the same. So let's go ahead and label that information. Okay, corresponding angles. That's when you take one angle from one triangle and match it up to its equal angle from the other triangle. So what's one pair of corresponding angles? Well, no, those are sides. So F and C, yes, that's one pair. So angle C from the big triangle and angle F from the smaller triangle. So notice that they have the same markings inside of the angles there. What's another pair of corresponding angles? A and D. Angle A and angle D are equal. And B and E, good. Okay, so once you identify the corresponding angles, then you can identify the corresponding sides. So the corresponding sides would be the sides that are opposite these angles. And we don't want to use the measurement of the sides. We want to actually use the name of the sides. So if we start with angle C and angle F, the side that does not touch angle C would be this blue side at the bottom, AB. Okay, notice that that's a segment, AB. And that corresponds to the side that does not touch angle F, so DE. So those are two corresponding sides. So another pair would be? Okay, CA and FD, good. Okay, CB and FE, good. So those are your corresponding sides. Now what this rule says that corresponding sides, the ratio of corresponding sides are the same if you have similar triangles. So ratio means that you're comparing two numbers, or you can also look at it as creating a fraction. So if I take AB and DE, notice that AB is equal to 4 inches and DE has a measure of 2 inches. So if I make a fraction out of that, 4 over 2, that's going to equal the comparison of another set of sides. So if I look at CA and FD, well, CA measures 6 inches and FD measures 3 inches. Now, you need to put it in the same order as how I did the other fraction. Notice that I did big triangle over little triangle. So now I need to do the same thing and take big triangle over little triangle. Notice that 4 over 2 is equal to 2, and 6 over 3 is also equal to 2. So notice these fractions equal each other. If you know that your triangles are similar, this will work every time. And I could even flip them over. I could have done little triangle over big triangle and done 2 over 4, which would have equaled 1/2, and 3 over 6 also equals 1/2. Now there's another way that I could do this as well. Let's say I take two sides from the same triangle. If I put 6 over 4, that came from the big triangle, and then I make a new fraction with the two sides that correspond from the smaller triangle. I have a 3 and a 2. Now what's important is that I line up the corresponding sides if I do it this way. So 6 corresponds to 3, and 4 corresponds to 2. And notice that 6/4 reduces to 3/2. There's a lot of different ways that you could set up your fractions in here. You're either going to take two corresponding sides and create a fraction, or you're going to take two sides from the same triangle and create a fraction. But then you have to make sure that it matches when you go create your second fraction. Now, this comparison is helpful when one of the sides of your triangle is unknown. Let's take a look at this next example here. So this is not on your handout, so just, mark this somewhere in your notes. Notice here you have a triangle inside of another triangle. And either you are going to be told that these two triangles are similar, or you're going to be told something about the triangles that leads you to believe that they're similar. So in other words, you'll either know all the angles are equal to each other, or it'll just say these two triangles are similar. All right, so we have triangle ABC. But then we also have this other triangle, EDC. Now the 3 and the 12 are showing you the measures of two sides of the smaller triangle. And the 8 is that side AB. And let's say that you want to find the length of BC. So you're trying to find from here to here. Now that's your unknown length, so if you want, you can mark that as X. Sometimes that'll already be marked for you. So you want to set up a proportion. That's what those two fractions that are equal to each other mean. It's a proportion when you have one fraction equal to one fraction. And so looking at that unknown X, you can either create a fraction with another side from its own triangle, or you can look for the corresponding side from the other triangle. What's the corresponding side to X in the little triangle? 12 inches, right. So BC is the base of the big triangle, and that corresponds to DC, which is the base of the smaller triangle. And so you could create a fraction of X over 12, because those two sides correspond to each other. Now you can make another fraction with two other corresponding sides. Okay, 8 and 3 are the only numbers that we have left, but you need to do it in the same order that we just did the other fraction. So we did X was from the big triangle, so that means we have to start with the number from the big triangle first, which is 8 over 3, the corresponding side. So we've just created a proportion, and does anybody remember how you solve proportions? Cross multiply, good. All right, so if you cross multiply, that means multiply diagonally, and X times 3 is 3X, 12 times 8, 96, and then you have an equation that you can solve for X, so divide both sides by 3, and X equals 32. And that is the entire length of BC, what you were looking for. So therefore, that solves your problem. Now, if you have a hard time looking at a triangle inside of another triangle, then by all means redraw this so that they're not inside the other. You could always do this. You could say, okay, I've got triangle ABC. That's pretty much the shape of it. And then I have this other triangle, EDC. And this one was 12 and 3, and this was 8. And if it helps you to see this problem a little easier because you've redrawn them so that they're separate from each other, then by all means do that. Do whatever you have to do to help you visualize this problem a little bit better. And then you can set up the same problem. So that's 32 inches. And notice that my drawing is not drawn to scale, so you can't just guess at what that length is. Because if the whole base is 32 inches, then that means that this little piece right here is equal to what? 20, right? Because 12 and 20 equal 32. All right, so the picture is not always drawn to scale. You cannot just assume based on one length that the other length is going to be proportional. The Pythagorean theorem. Some of you guys have seen this before, but maybe didn't think about it in words. Here's the definition in words. The sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. Anybody? It's written up here. Anybody a Wizard of Oz fan? This. Okay, yes, so very, very possible. Pythagoras, very famous, did a lot of stuff in philosophy and math and so on. But in The Wizard of Oz, the Scarecrow tries to say this when he gets his new brain. His new brain has a little trouble, okay, because he does not say this right in the movie. So the writer should have consulted a mathematician just to make sure that they got that right. But anyway, this is what this means mathematically. You have a right triangle, and first of all, you have to understand the vocabulary of what's in here. You've got legs of a triangle. The legs of a right triangle are the sides that touch the right angle. So this is a leg, and this is a leg. And then the hypotenuse, okay, that big word there, is the side that is opposite the right triangle, also the longest side of the triangle. So that's the hypotenuse. So what this is saying is the sum of the squares of the legs. So in other words, you have to square the lengths of the legs. We've marked the lengths as A and B, little a and little b. So the sum of the squares, A squared plus B squared, okay, that's the sum of the squares, equals the square of the hypotenuse, which we marked as little c. So that equals c squared. And so you probably are familiar with this, but didn't know that that's what a squared plus b squared equals c squared means. You've got legs of a triangle and hypotenuse of a triangle. So make sure you're familiar with that vocabulary. And so you have this formula. This formula can only be used on a right triangle. I see students make the mistake of trying to use this on a regular triangle that doesn't have a 90-degree angle, okay? So it can only be used on a right triangle. And so let's take a look at an example where you would use this formula. Here you have a right triangle. You can tell it's a right triangle. Why? Because there's the little box in angle C. And so you're given sides of 9 and 12. So which sides did they give you? Both the legs. Good. So they gave you both the legs. And so that means you need to find the hypotenuse. So knowing the formula. Now, I went ahead and rearranged the formula here because we're trying to find C. So C squared equals A squared plus B squared. So we substitute in what we know. Now, it doesn't really matter which leg stands for A and which leg stands for B. Typically, little a is the one that's across from angle A, if you have an A in your triangle. And then little b is across from angle B. Okay, it doesn't matter, though. It'll work either one. What's important is that the hypotenuse is always C. But substituting in a 9 and a 12 for A and B, make sure that you're following order of operations. Order of operations says that you have to square each of these numbers first before you can add them. So 9 squared is 81, and 12 squared, 144. Then go ahead and add these two numbers together, and we get 225. Now, C is not equal to 225. C squared equals. So you're trying to figure out what would you square to get 225. But the easiest way to do that is to think of the opposite of that. The opposite of squaring is square root. Good. So if you take the square root of C squared, that gives you C. And then the square root of 225. Okay, 15 is correct. So let's take a look at this application problem here. In a 25-inch television set, the length of the screen's diagonal is 25 inches. Okay, maybe you didn't know that. When you're looking at TVs, okay, you wanted a retro one, so here's the TV you're looking at. In case you didn't know that, when they tell you it's a 25-inch TV, they're saying that from one corner of the screen to the other, that's 25 inches. So they say that the height is 15 inches. Now let's say you're building a custom cabinet to put this in. You want to just see the screen in there. And so you need to make sure that it measures correctly. And so you need to know what the width is so that you create this box that goes around it. All right, so our screen here, the corners create what? A 90-degree angle. So you have to do some inference in here, knowing that the corners of the TV are 90-degree angles. And so we know that the diagonal is 25 inches. The height is 15, and so you're looking for the width. So this time, what information of the right triangle were you given? A hypotenuse and one leg. Good. So this is how I've substituted it into my formula. W is one of the legs, so W squared plus the other leg, 15 squared, has to equal the hypotenuse squared, 25 squared. Again, order of operations is very important. You need to first square each number. So 15 squared, we just learned from the previous problem that that's 225. 25 squared, 625. Good. So now to get W squared by itself, we need to subtract the 225 from each side. Good. So that gives us W squared equals 400, and now our last step is square root of both sides. All right, so W equals 20. If your square root doesn't come out evenly, you need to pay attention to what it wants your answer in. Maybe it wants you to simplify your square root and leave the square root in the answer. But it might say round to the nearest hundredth or something like that. So that means it wants you to use your calculator to find a decimal approximation and then round to whatever it says. So make sure you're paying attention to how it wants your answer. Okay, so we're in section 10.2. So you're going to have several different types of problem in here. And this one, it just wants you to find the missing angle in the triangle. And so what information do you need to know to solve this problem? Okay, so that the angles inside of a triangle add up to 180. So knowing that, you need to first, and there's a lot of ways you can do this. You can just, in your calculator, you can say 180 minus 49, and then minus 72. You can do it that way, or you can go ahead and add up 49 plus 72 first, and then subtract that from 180, whichever one you feel more comfortable with. And so what is our answer for the measure of angle A? 59, okay. Degrees for that one. All right, let's see if you guys were right. Good job. Okay, so here you have two lines that intersect, and they formed two triangles out of them. And they want you to find all of the numbered angles in there, 1 through 5. Now, that may mean that you find them in order from 1 to 5, but that doesn't necessarily, mean that you have to do it that way. What I would recommend is that you sketch these pictures onto your paper and find the angles in the order that you feel comfortable. And then after you've done that, then type in your answers to Math Excel one at a time. All right, so if we look at this problem, angle 1 would be the most natural one to find. Okay, so I heard 31. How'd you know that? Okay, so 59 and 90 is 149, and then? Okay, 180 subtracted 149 gave you 31. So angle 1 is 31. What else do you know is 31? Angle 3. Why? What do you know about angle 1 and angle 3? Yeah, what's the term? Vertical. They are vertical angles. Good. So notice I didn't do that in order. I found angle 1 and then I found angle 3. Now, what else can we find? Okay, so angle 2 and angle 1 are supplementary. So that means what? Okay, so it's 149 because you did what?
I subtract 180 minus 31.
Okay, so subtracted 180 minus 31, which is 149.
I'm making sure I did right.
Okay, so this one is 149. This one was 31. And now what else do we know?
Angle 4 then is vertical to angle 2.
Angle 4 and angle 2 are vertical. Good, so they're both 149. And then all we're left with is angle 5. Okay, so in this triangle, you know that the one angle is 61, the angle 3 is 31, and all three of those angles have to add up to 180. Okay, so then again, lots of different ways you can look at it. But if you take, oh, can't see that very well. If you take 61 and add 31, that gives us 92, and then 180 minus 92, 88. So this angle here is 88. All right, so we had answers of 31, 149, and 88. So angle 1 is 31. Nice work. Angle 2 was 149. Excellent. Angle 3, 31. Excellent. Angle 4, 149. Good job. And angle 5, 88. Fantastic. Okay, so lots of diagrams where you have to use your knowledge of triangles. You might have to use your knowledge of triangles and parallel lines. And then the other types of problems you're going to see are similar triangles. It says explain why the triangles are similar, then find the missing length x. Okay, so time to think about your choice, and you're going to show me your choice 1, 2, 3, or 4. And so choice 1, all right triangles are similar. Choice 2, both triangles contain right angles and a corresponding angle of equal measure. Thus, two angles of a large triangle are equal in measure to two angles of a small triangle. Choice 3, the Pythagorean theorem states that a squared plus b squared equals c squared, thus the corresponding sides are proportional. And choice 4, both triangles are right and scalene. I don't think they made this one easy on you. Okay, so choice 1, 2, 3, or 4. All right, so a lot of 2s. Good job. All right, now, 4 was a true statement, but is not the reason why they're similar. And 1 and 3 are not true at all. Okay? But let me explain that choice too. It was very wordy. But it said both triangles contain right angles and a corresponding angle of equal measure. So both right angles and a corresponding angle. So that means that you have at least two angles that are equal to each other from each triangle. That's basically what the second sentence said. Okay, so you have two angles that you know are equal. Well, then you sort of need to deduct that the third angle must be equal. Right, because if they're all equal to 180, then when you subtract those other two angles, you're going to get the same answer in both triangles. So two triangles are similar when their corresponding angles have equal measure. That's what it comes down to. You got to make sure you're picking the choice that talks about their angles being equal to each other. So now I want you to find the missing side of x. How did you do that? But why did you know to divide it in half? Okay, so the other numbers were given, and it gave you a ratio of either, no, not really double if you're going back to x, but what you said it, the opposite of double is half. Okay, but you may have done some of this in your head, but remember, if it's a show your work problem, you need to show me your work. But essentially, you saw that if you pick some other pair in the triangles. So what's a pair of corresponding sides? 13 and 24. So if you set up 13 and 24, okay, good. 13 and 26. All right, good. Notice that since they're right triangles, you can use the knowledge of what you know about right triangles. 13 is a hypotenuse, and so therefore you need to look at 26 for the other hypotenuse. So she saw that that makes a ratio of 1/2, so 10 and x need to also make a ratio of 1/2. Or the other way you can do this is set up another fraction with the x. Is x going to go on the top or on the bottom? The top, good, because it comes from the same triangle as the number 13. And so therefore 10 goes on the bottom. And again, feel free to reduce if you want. This reduces to 1/2 equals x over 10. And you can use the comparison of what you see in fractions, or you can just cross multiply. And you have 2x equals 10. So when you divide by 2, x equals 5. Now I caution you if you don't practice the proportion method, because your numbers may not make a nice little fraction like 1/2. And so the proportion is the best way for you to solve at any time. So make sure you're practicing that. All right, our answer here is 5. Let's take a look at some of the application problems that you're going to see. Fantastic, by the way. Okay, it says two angles of a triangle have the same measure, and the third angle is 15 degrees greater than the measure of the other two. Now, it already drew the picture for you, but that might not always be the case. You could draw a picture from what was given. Okay, it says two angles have the same measure, so they drew a triangle and they marked two of them with an x because they're both the same. The third angle is 15 degrees greater than the measure of the other two, so that's why the third angle is x plus 15. Find the measure of each angle. So what can you do with these expressions? Add them all up. So x plus x plus x plus 15, it should equal 180 because they are angles from the same triangle. Okay, so I'm not going to solve the rest of it, just so you guys know how to set it up. And then from here, you solve for x. All right, so here you have a picture of a person standing in the shadow of a really tall tree. And so if you know something about the angle of the sun and shadows, if he is standing in the shadow of that tree, then the top of his shadow is going to line up with the top of the tree's shadow. So this creates similar triangles. It tells you that the person is 6 feet tall, and he's standing 110 feet from the base of the tree. The tree casts a shadow of 120 feet, so from here to here, it's 120 feet. And they could have stopped there and not told you any more information, because then you could have figured out that his shadow was 10 feet. But they went ahead and told you that his shadow was 10 feet. All right, so notice that you have a smaller triangle made by the person and his shadow and the angle of the sun, and a larger triangle made by the tree and its shadow and the angle of the sun. If you need to separate out these triangles, then go ahead and do that. So this is 6 and 10. Okay, so here's the tree. And we know that the shadow of the tree, so from here all the way to the end of the triangle, is 120. The information of the 110 feet is irrelevant. We don't actually need it for this problem. They want you to figure out the height of the tree, which that would be our x. Okay, so the height of the tree corresponds to the height of the person. So we can make a fraction out of that. The height of the tree corresponds to the height of the person. And so therefore, the length of the shadow of the tree corresponds to the shadow of the person. Okay, so the 120 needs to go up top because it matches up to the x, and the 10 goes on the bottom. So any questions on how I've set this up? Notice that I can reduce this because the zeros cancel. And so when I cross multiply, I just have x times 1, which is x, and then 6 times 12, which is 72. And we were talking about feet, so the tree is 72 feet. This method is actually used to find heights of objects that are very difficult to measure. And so I believe that they used this method to figure out the height of the pyramids, because you can't really drop a line from the top of the pyramid to the bottom of it, right? So this method is actually used, used in surveying and lumberjacks, okay? So this is a very applicable type problem. So let's see if we did that right, plugging in our information of 72 feet. Excellent. Okay, one more. I won't work it all out, but just to make sure that you guys are thinking about the types of triangles that you have here. What kinds of triangles do you see here? 90 degrees. So that's one information that you can use there. Okay, a ladder up against a house also forms a right triangle. You have to assume that the house is 90 degrees with the ground. If it's not going to last very long. Okay? So again, these are some of the things you want to think about when you're setting up these problems. So your homework is section 10.2.